Final answer?
3x.
Thank you. So this is the function that gives the instantaneous rate of change of this function at any point. There is no need to say at any point where the function is differentiable. We know it's differentiable everywhere. So if you say, I'm driving, if this is, let's say, this function represents the distance, and you say, calculate your speed when x is 3 hours, I will tell you 3 times 3 is 9 miles per hour. If you say when x is 4 hours, I will say this is 4 times 3, which is 12 miles per hour. This is the function that gives us the rate of change of that function at any point for any x value. We will be able to find the instantaneous rate of change.
I have a question.
Please do.
Do you have to move the fraction in front of the limit when solving it?
The limit, this is constant?
Yes.
You don't have to, but why not? I know the limit law that we discussed last time. What is this? As long as this limit exists. So I'm using what we learned before.
Okay, that makes sense.
But you do not have to. But you have more work to do. So if you keep it in here, then you will have to distribute it everywhere. Do you want to distribute a fraction that you can factor out? Do you want to distribute it to all terms?
No.
No. So always try to make your life easier, especially when you have a fraction in there that you can. The fraction is not going to go away. It will wait for me patiently. Look how patiently it is waiting for me outside. I don't need this. It complicates things. So I take it outside. Yes. Next question, please.
When there's when you're writing the answer is not that the limit h to 0 equals 3x, right? The answer is just 3x because you got rid of the limit when you did the plugging in.
Right. So this limit is 2x. When age approaches 0, the limit is 2x.
So the whole thing is just 2x, and then you deal with a fraction, which leaves you the final answer of 3x.
That's it. Excellent.
Okay.
Absolutely. Okay, ready? Let's move on to pages 136, 137. I would like to determine the equation of the tangent line, so something like even, let's say, 20. Let's determine 20 first, and that is back to 135. And we have f of x equals negative 1 over x. And they are asking us to find the equation of the tangent line to the graph of that function at 3 different points. Please choose one point. We're not going to do it 3 times. We're going to do once slowly, and then you can do it again for the others. Choose any point for 20. Negative 1, 1, 2, negative 1 half, or negative 5, 1/5. It doesn't matter.
We do b, 2, negative 1 half.
That's it. Perfect. Okay. So they're asking us to find the equation of the tangent line to the graph of f of x. That's the question here. So we know how to graph this function. It's a very important function. Let me just get rid of some of the pages. So it's a very important function. We can graph it with the calculator, but we know that 1 over x, we graphed 1 over x. I hope you remember this so we don't have to spend too much time on it. This is the graph of 1 over x. But this is not exactly what we have. We have negative 1 over x. So for negative 1 over x, the positive function part of the function will become negative, and the negative part of the function will become positive. So I will do this for you to understand that this is the function in question, not the red one, but the purple one, which is -1 over x. So we are asked to find the equation of the tangent line to the graph of this at 2, -1/2. So I'm going to say this is the point. Let me use a different color, maybe blue, right here. So they want us to find the equation of this line. This is the tangent at, I'm going to call point P, 2, -1/2. Who can give us the equation of the line having the slope and the point? The point slope form, anyone?
Y equals mx plus b.
That's a perfect one, but it's not what I'm looking for. This is the y-intercept, slope-intercept, or slope y-intercept form. I need point slope form.
Is it y minus y1?
Very good.
X minus x1 in parentheses.
Good. Perfect. I'm happy I have a point. No big deal. This is 2 and this is -1/2. But I'm missing a little piece. It's not a little piece. It's a very important piece. So how do I determine that? Can anyone tell us how to proceed?
Isn't a slope an average rate of change, so we'd have to do the difference quotient?
The slope is not the average rate of change. The slope of the tangent line is not the average rate of change. The slope of the secant line between 2 points will be the average rate of change.
Isn't it y2 minus y1 divided by?
We do not have 2 points.
I just know we have to use a different quotient at some point, so.
So what did we say a few minutes ago was the instantaneous rate of change? How do I determine the instantaneous rate of change? What do I have to calculate?
The derivative.
Correct, which means I have to put 2 concepts together. Which concepts? The concept of and the concept of the
Difference quotient?
good. So then now please tell me, anyone, what to write. Of course, the tangent at P. The slope of the tangent at P will be the instantaneous rate of change when, of course, of function f of x, when x equals how much?
2.
Very good. Good. So whatever I get, I have to plug in 2. Great job. So how do I get that? How do I start?
The limit of...
I have to start perfect, but I have one more thing to write before it. I cannot start with the limit. I have to write what it is. What is the beginning?
Oh, m. Oh, f prime. F of x prime.
Yes, we say f prime of x. Very good. So indeed, limit as age approaches 0 from, and the definition again,
Oh, f of x minus h, x plus h minus f of x over h.
perfect. And now we put the function in. Do not drop the limit operator. Everything stays so far. Yes? And then
Be the f of 1 over -1 over x plus h
great job.
minus -1 over x.
Very good.
In parentheses, both of them.
Oh, excellent. I was too lazy to put parentheses, but you told me parentheses, so that's awesome. Good. Now we have to find what?
common denominator.
Excellent, great job, yes. So what is the common denominator, Shvam?
Maybe x plus h.
Can anyone explain what is the least common denominator?
It's going to be x times x plus h.
They have nothing in common. Thank you very much. Who was that? Was Michelle?
Yeah.
Thank you. Do we all understand why the least common denominator is x times x plus h? Everyone?
Yes.
Okay. What do I, sorry, ran out of room. I always do. So what do I multiply the top of this fraction by?
X.
Thank you. What do I multiply the top of this fraction by?
X plus h.
That's why repetition is so important. And I know, my apologies, you will always hear the same thing over and over. I'm sorry. I'm sorry. Good. So what do I write at the top here, from here? It's hard to see. There is
Negative x
very good. And then plus?
x plus h.
Good. What do you expect to happen immediately at the top? And also remember, this is h over 1.
The negative x and the positive x cancel out.
They better. So this is limit as h approaches 0. How do I divide two fractions?
Negative of the increase.
Very good. So the top is h over x, x plus h, and the denominator now gets flipped into?
1 over h.
Good. What has to happen next? For sure. I'm anxious for it to happen because it's the second thing that has to happen for every difference quotient.
The h cancels out.
Absolutely. It simplifies. Goodbye. And now the final answer.
1 over x times x plus h. Well, not for the final, but then that's how it's simple.
But then you have to give me the limit. You cannot say without the limit then. You either apply the limit and give me the final answer, or you start with the limit. You cannot drop the limit operator till you apply it. So?
The limit as h approaches 0 is 1 over x squared plus xh.
We'd never multiply factors in the denominator.
Oh, so I just had to say that first?
Yeah.
Oh, okay. Thank you.
Never multiply factors in the denominator. We wrote that before, I think, but let's write it again. Do not expand denominators, please. Please. Don't waste your time. Okay, can anyone finally give us the final answer? This is only the derivative. We haven't even plugged it in and we don't have the equation yet.
I got 1 over x times x.
Perfect. 1 over x squared. Exactly. X times x. When h approaches 0, I have x times x, which is x squared. Great job. Look at how many steps we needed. So the first derivative, or the derivative of this function, at any point where it is differentiable, but we are only interested in what happens around 2. Good. So now, how do I determine the slope exactly at 2? As I gave a few examples before, but I managed to mess up my papers. No, it's not this one. Of course, it must be the last one. Of course, it is the last one. So we have the function, we have the derivative. If I want to determine the rate of change at different points, like when x is 3, I plug in 3. When x is 4, I plug in 4. When x is 10, I plug in 10. So then, page 5. Say it again.
It'd be 1 over 4.
Indeed. F prime of 2 is the slope of the tangent at P, which is 1 over 4. Excellent. Why 1 over 4? Because F prime is 1 over x squared, and I plugged in 2. Great job. Who said that?
Jackson.
Thank you. Good. So I have finally everything I need. So I have y minus negative 1/2, which is y plus 1/2, equals 1 over 4, and x minus 2. And yes, we will distribute. I will distribute and get 1/4 x minus 1/2, and then I subtract 1/2. 1 over 4 times x, 1 over 4 times 2 is 1/2, or 1/4 times 2 is 1/2, but then I have to subtract 1/2, and this is negative 1. So the equation of the tangent line, this line, this equation here is y equals 1 over 4x minus 1. Right here. We determined the slope of the tangent line by determining the derivative and plugging in 2. And then we finished up the algebra with the equation of the line, and we found that this line is guaranteed to be 1/4 x minus 1. Any questions? Any questions?